All right, hello, welcome back, my ferocious physics students. We're going to be taking a look again at projectile motion, and this time we need to look at sort of solving this problem and show you how to break this one up. Okay, so we have a 30-degree angle, we chuck the ball, and we want to make sure that the ball lands on our target, which is 100 meters away. So if we chuck a ball at a 30-degree angle, it's going to hit at 100 meters exactly. How can we figure out things about this? Well, I told you earlier that for any projectile motion, the most important two questions that you initially start off with is what is my velocity in the y direction and what is my velocity in the x direction, because these two directions are independent of each other. X is going to determine distance and y is going to determine time in the air because gravity is pulling down in the y direction. So gravity is an opposite acceleration vector against this one. All right, so let's go ahead and check this out. So my velocity in the y direction, what is that going to equal? So velocity in the y direction is going to equal, so if we use our trig functions, let's use the SOHCAHTOA, let's use the SO portion. So the sine of this angle is going to equal my velocity in the y direction divided by my initial velocity, and that's what we call this one. We could say that this is just our velocity initial. We don't know exactly what that is right now. Okay, so let's say that. So velocity in the y direction is going to equal the sine of 30 degrees, right? Which is going to equal my velocity in the y direction. That's what I want, my opposite, divided by my velocity in the initial direction. Okay, so what do I do with that? Well, let's go ahead and take the sine of 30. So the sine of 30 equals 0.5. So let's go ahead and just keep going with this. So 0.5 is going to equal Vy over Vi. Right? So that means that velocity in the y direction is going to equal 0.5 times Vi. All right, so let's kind of hang on to that for just a second. Now let's look at my velocity in the x direction. So my velocity in the x direction is going to equal the cosine of 30, right? Because I want the adjacent over the hypotenuse. So my cosine of the angle theta. So here's my angle in question. And so the cosine of 30 is going to equal my velocity in the x direction divided by my velocity in the initial direction. So what's that going to equal? The cosine of 30 equals 0.87. So just like I did up here, we can kind of shortcut this. My Vx is going to equal 0.87 times my initial velocity. Now, have I gotten any closer to my answer? Yeah, I've figured out a few things. I understand that whatever my initial velocity is, half of it is my vertical velocity, and 0.87 of it is going to be my velocity in the x direction, because anything thrown at an angle is both thrown up and over. You need to separate those two things to figure out anything about what's going on. All right, so here we go. So these are two kind of important functional pieces, and like I said, you always want to break it up into those two vectors and figure it out from there. All right, so let's see. What do we do next? All right, let's take a look at this. Acceleration, right? Average acceleration or a constant acceleration is going to equal a change in velocity over time, right? So that means that the change in velocity equals acceleration times time, right? So so when I'm thinking about my vertical velocity, I know that my vertical velocity is going to go up, right? It's going to go up until gravity has taken it to this highest point. And at the highest point, the thing is going to stop going up and then start going down. So there will be a point when my velocity equals 0. And that's going to be the highest point of my arc, when essentially my projectile stops moving up, right? All right, so change in velocity, we could say, is a velocity final minus velocity initial. equals a times t. So we could say my velocity final is 0 minus my velocity initial equals negative 9.8, because gravity is taking away from my velocity. So here we go. So I could just take away this 0 right here. So negative velocity initial equals 9.8 times my time. Well, I learned up here that my initial velocity in the Vy direction, and this is, I could say my velocity initial, because what I want to know right here is my velocity in the y direction, because only the velocity in the y direction has gravity acting on it right here. Okay, so my velocity in the y direction, right, which is my initial velocity in the y direction, that's what I want to know. And we could just insert this. So what I could say is I could say if Vy equals 0.5 times my initial velocity at the angle, I could say 0.5 velocity initial equals 9.8. What I did is I just took this negative by both sides times t. All right? So let's go ahead and divide both sides by 9.8. Divide both sides by 9.8. And I get that velocity, let's see, I'll end up here, I'm going to say 0.05 times my velocity initial equals my time. All right, well, that's pretty cool. So I've got kind of this little substitution for time that's going to go in here. So what could I do with that? All right, let's go ahead and say this. So actually, but at this point right here, if you think about it, this point that we just solved for right now, we just solved for the initial velocity, or the final velocity being 0, right? So what we just solved for using this was the time it would take for the velocity to become 0. So what would be the time that it would take for the total amount of time? Well, if it takes amount of time to get 0, it's going to take that same amount of time to come down. So if I just took this and multiplied it by 2, so I could say the time is actually going to equal, right? I could take this and multiply it by 2. The time is going to equal 0.10 times my initial velocity. All right, so take this times 2, it's going to give me the total time. And I may just want to use half the time at one point. Like maybe when I'm looking at how high this thing goes, right? And that was one of our questions right here. How high will it go? Maybe I'll just use half of it, right? But the total time is going to be the time it takes it for this velocity to become 0, and then for this velocity to become the same going back in the negative direction because of gravity. All right, so here we are. So time equals 0.10 times my initial velocity. Now let's work with my horizontal velocity for a second. So we know that my distance is 100 meters, right? So I told you earlier that distance always equals my velocity in the x direction times my time, and that should make sense. If I'm going 5 meters per second for a second, I've gone 5 meters. All right, so if my distance is 100, okay, what is my velocity in the x direction? So my distance is 100. What is my velocity in the x direction? Well, I figured out using my trig functions that my velocity in the x direction is going to be 0.87 times my initial velocity, whatever this is, right? And then what is that? And then that's times time. Well, I figured out over here that my time was 0.10 times my velocity in the initial direction, right? Get rid of that little point right there. So here we go. So now I've actually gotten somewhere. So look at this. What can I do with this? Well, I'm going to go ahead and distribute out my velocities here, right? Because I got velocity initial times velocity initial. So let's go ahead and do that. So I've got 0.87 times, so I could go ahead and pull my VI out. So I got 0.87 times 0.10, and that's going to equal 0.087 times VI squared. All right, so let's go ahead and get rid of that. So now, if I take this, and I'm going to isolate my initial velocity, I got 0.087 times velocity squared, and then I've got 100 right there. So let's go ahead and divide both sides by 0.087, 0.087, 0.087. And then all I'm going to have to do is take the square root of that, right, to get VI by itself. So I take the square root of 100 divided by 0.87, and I get my velocity initial equals 33.9 meters per second. Well, there we go. So this is 33.9 meters per second. All right, so there we go. I figured out my initial velocity that I'm going to chuck it at, and that's the total velocity it's going to take to go exactly 100 meters, right? And now that I have that, I can figure out a whole bunch of other things. And so I could take this, and I could actually take my trig functions. Now that I know my hypotenuse right here, I could actually figure out my velocity in the y direction, and so I could figure out my total time, because I could use this right here to figure out my total time. I could take this, and I could multiply my 33.9 times 0.87 and multiply that times my total time, and I could get my total distance, which I already know is 100 anyways, but say you didn't have that 100. And so there's all sorts of awesome things you can do. But here's the big takeaway from all of this, okay? When you're doing projectile motion, okay, here's the first thing you want to do. You want to break everything up into its Vy and its Vx, right? You want to break everything up into its x and y components. So you want to get the y component and the x component, and then in order to figure out the height, right, you can use the acceleration of gravity working on the Vy, and to figure out the horizontal distance, you could use the Vx times the total time, which you could figure out also from using the gravity and the acceleration and some of our acceleration rules. So taking up enough time with this video, so we're going to go ahead and stop this.